Alright, now you've been waiting for those word problems, so here they are. Okay, now we're going to look at a projectile being fired vertically, yada yada yada, and we want to know when it's going to be back on the ground, and it's going to be less than 128 feet in the air. Okay, well, in order to do this, you do have to be familiar with one formula, and yes, on a quiz I would give you this formula, but the book kind of assumes you know it. But h sub f, our final height for whatever projectile, in English units is going to be negative 16t squared plus our initial velocity times time plus our initial height. Okay, so for doing part A here, okay, I want to know what instant I'm going to be back at the ground level. Well, ground level is going to be 0 feet high, and again, since I was launched originally from ground level, that's a height of 0 as well. So basically my final height is 0. I've got my negative 16t squared plus my initial velocity is the 128 that's right there, a times t, and then my initial height is 0 as well, which is probably a little bit silly to put on there. Okay, but basically what we got here is a situation with a negative lead coefficient, so I'm going to take everything over to the left side just to make sure I get myself a positive lead coefficient. Okay, and then from there, well, that 128 is not such a weird number when you realize that 16 divides into it evenly. So I can actually factor out a 16t and then be left with t minus 8. A fairly nice equation to have, because that gives me quickly the answers of 0 and 8. Okay, well, at what instance is it back on the ground? Well, it looks like I have two answers, but the t is equals 0, well, that's basically the second that it's fired. And that's not what I'm interested in for this. I'm interested in when he's back on the ground, so that's the 8 there. So it takes 8 seconds for this particular projectile to make its way back to the ground. Okay, for part B of this, okay, I went with the height to be less than 128. So height less than 128. Okay, now what we need to recognize is the height is represented by this formula, which, better yet, is maybe this expression over here. So basically that's what I'm going to plug in for the h. So negative 16t squared plus 128t, etc. is going to be less than 128. Alright, now at this point, again, now I have an inequality because I was talking about being less than. Okay, so now I am talking about the stuff that we've basically done so far in this lesson. Okay, now first thing first, I want to have myself a 0 on one side, and I also don't want to have a negative lead coefficient. So in this case, I'm actually going to take everything to the right side. So now I've got 0 less than positive 16t squared minus 128t, and then plus a 128. Okay, again, since it was divisible by 16 earlier, I can divide both these 128s by 16, just to give myself a little nicer situation to look at. So I've got 16, I've got t squared minus 8t plus 8. Okay, and admittedly, if you wanted to, you could divide the 16 off of both sides to get rid of it altogether because it's not a variable. Okay, don't ever do that with variables, but if it's just a number, you can get rid of it by dividing both sides. Alright, but I'm just going to ignore it for now. Okay, and I know you don't want to see me do the quadratic formula again. I know that just excites you to see me do that. But anyway, we're going to get this, and hopefully you can just trust me that by doing the quadratic formula, I ultimately get t equals 4 plus or minus 2 root 2. Okay, and that gives us our critical points. Alright, so basically those are going to go on the map, number line, map. And one thing that might be nice in this word problem scenario is, I mean, I've probably never told anybody that it took me 4 plus 2 root 2 minutes to go anywhere. So even though it doesn't say in our directions here, I think it's probably better off to go to a rounded answer for this. So the 4 plus 2 root 2 is about 6.8, and the minus version of that gives me approximately 1.2. Alright, so putting those guys on our number line, although hopefully intuitively this wouldn't be necessary in this problem, but just for the sake of argument, there's my critical values. Okay, and again, I want to plug those back into one version of this thing or another to make sure what works and what doesn't. So again, I'd test 0 over here by plugging in 0. I get kills of everything here. I get 0 less than 128, and yeah, I like that. So we're good here. Okay, and as I plug in something like 5, again, I'd have to do this manually, but if I did plug in something around 5, I definitely would get something that didn't work out for us. So very frowny face right there, and then as soon as I plug in, let's say 18 bazillion, when I do that into this expression, I definitely get something positive, and this thing does work out to be then greater than 0, so again, I'm just happy as a clam over here. Alright, so when will the height be less than 128 feet? Okay, alright, well, it's less than 128 feet from the time it takes off until it gets to 1.2. So from 0 to 1.2, notice my implied takeoff and landing times come into play here. Okay, again, I'm going to use a bracket or a parenthesis because it did say less than specifically, and we're not doing the or equal to also be rounded, so that just kind of seems wrong to put a bracket on there. Union, okay, and on the way back down, it's a 6.8, and then again, we figured out that 8 seconds earlier because basically that's when it stops. Okay, so here would be our answer, kind of better in context for this. So less than 1.2 or greater than 6.8 seconds on the whole trip. So there's the interval notation answer. Of course, a worded answer might be good, but I'm not going to bore you with any more of this talk on this problem. Alrighty, let's do a geometry S1 here. Got a rectangle with perimeter 44 as an area of at least 120. Alright, well, as soon as I start using words like perimeter and area with a rectangle, those are a couple of formulas we probably should start with. So P equals 2W plus 2L. Make sure that looks more like a W. Okay, and then again, area equals L times W. Okay, now this does ask us about the length, and admittedly with rectangles, the length and width can be pretty much interchangeable, so just be cautious of that as we go through the problem. Okay, well, anyway, our perimeter is 44, and that's going to be 2W plus 2L. Alright, and well, that's as far as what we know so far. Let's go over to this area. We want the area to be 120 square feet at least, so that means we want our area to be greater than or equal to 120. And kind of like in the last problem, the area is represented by that combination of letters, so basically we can do length times width has got to be greater than or equal to 120. Alright, now the problem is we have two different letters, and of course this over here is going to be the cure. Okay, and again I'm talking about the length here. So I want the length as my variable, so I'm going to replace the width. And so what that means over here is I want to solve for width so that I can replace it with something with an L in it. So 44 minus 2L is going to be 2W, and then dividing through by 2 gives me 22 minus L equals W. Okay, so now taking that expression for W back over here, I get myself something like L times 22 minus L greater than or equal to 120. And then just sorting this guy out, I get a negative L squared. I'm going to cheat and switch the order. Plus 22L greater than or equal to 120. Again, just like in the last problem, I've got this issue where I don't want a negative on my lead coefficient, so I move everything to the other side and make him positive. So L squared minus 22L, and then it's going to be a plus 120. And conveniently, this guy's going to factor. Now, of course, they won't always factor, so just be careful. Okay, now the 120 and making a 22, that's a very convenient 10 and 12. Okay, so there's my critical values. I get 10 and 12. Okay, and then again, picking various values. Okay, I want to be 0 greater than these guys, so basically what I'm looking for here is negative to be happy. So when I plug in like 2, I get a negative here and a negative here, and those are two negatives make a positive, so I don't like that. Then as I plug in 11, I get a positive here and a negative there, and it gives me a negative result, and I want 0 to be greater than this negative number, so here I'm just happy as a clam. And then when I plug in 18 bazillion, again, I'm just not very pleased by the outcome. So basically right there is my good stuff. Alright, so I'm looking at this, and then so there's my graph version of the answer. So at what bounds must the length of the rectangle lie? It must lie between 10 and 12 feet. And we could slip in the word inclusive or something like that if we really wanted to, but there you go. Okay, that's the last of it. Hopefully you're still awake, and I'll see you guys in class.